Welcome to ClickMyProject.com. Now we discuss about the product for Unified VLSI architecture for photocore transform used in JPEG XR. Next we see the abstract for the product. JPEG XR, an emerging image coding standard for JPEG committee, is growing its popularity owing to its high image quality and compression capability while requiring low computational cost. It is designed to support high dynamic range and high definition formats. On the basis of the above observations, it is very suitable for real-time embedded applications, especially digital cameras. Therefore, the demands of very large-scale integrations implementation have become more and more important. JPEG XR uses a hierarchical two-stage lapped bioorthogonal transform to convert image data to the frequency domain. The transform is based on the photocore transform. It requires a small number of integer processing operations for the lifting structure. At two transform stage, the POT is optical whereas PCT is always performed. The unified VLSI architecture of very large scale integration architecture without better files that can perform photocore transform in JPEG XR image compression is presented. The proposed architecture can achieve the unified architecture designs which supports three elements operations of PCT, and it has a characteristics of lower hardware cost, shorter critical path and lower power consumption, and more efficient hardware utilizations and regular structure for VLSI implementation. Finally, the implementation of ultra-field programmable gate array devices validates the effectiveness of the data. In this paper, a unified architecture that is capable of implementing their basic operations of BCT is proposed for the first time. We attempt to design an effective architecture with lower area cost and lower power consumption and shortest path latency. Next we see the flow diagram for the product. We apply the 8-bit data bits, binary data bits for overall catalog head order architecture. This overall PCT transformation architecture to consist of the shifter logic and max elements and the adder functions and the multiplier elements for overall addition process. Overall transformation process. So we implement the different kind of adders to be presented in overall real-time based process. We select the catalog head order for our required PCT transformation architecture and the shifting logic to apply to the shifter function and the selection logic based on the shifter output to be applied in the constant multiplication architecture. We implement the parallel multiplier for every weighted logic based multiplication operations. This architecture to present the 16-bit output data bits and to passing the another one addition function and max selection logic and the shifting operation. This structure to array formation for overall PCT transformation functions. This architecture finally we addition the shifting output data bits and to produce the overall transformation output data bits. This PCT transformation architecture to reduce the circuit complexity and to reduce the power and area and timing for overall output performance. This architecture to implement the 8-bit operations and to produce the 16-bit output data for all the process. And finally we got it to the 32-bit output results for our transformation output results, and we implement the inversing logic to also to perform the inversing output functions and to reduce the inverse transformation output data bits for overall architecture. But we implement only the transformation architecture for PCT formation structure. The photocore transformation mainly focused by the XR based JPEG image and to get it to the image pixel data and to apply to the transformation architecture and to produce the transformed output image for overall output functions. But we implement only focused by the architecture for our 8-bit PCT transformation architecture. These are the final flow diagram for the process. Finally, we see the output for the product. Our PCT transformation architecture to develop in the Xilinx software. Just to double-click the Xilinx IC project file, then to open the software and to go into the simulation process. The simulation process to apply the any one of the input data bits and to produce the transformation output data bits and to how to function for the intermediate architectures. We just apply to the input data bits and to apply the clocking signals. Then to activate the reset function for every shifting control functions and to select any one of the logical operations, and again second mux selection logic for it. Then to remove the reset operation for required architecture. This is the final output for required selection process for our required transformation output for every 8-bit data bits. These are the transformation output for the architecture and to produce the shifting and elements for overall addition multiplications element for required architecture process. These are the final PCT transformation output for our simulation process. Then we go to the implementation architecture. Implementation architecture to analyze the RTL technological diagrammatic representation for required our VHDL code. These are the transformation architecture block for logical diagram operations. Then go to the technology diagram. The technology diagram to represents a FPGA kit implementation for overall architecture. Then go to the design summary for analyze the how many area to be consumed for overall architecture process. These are the device utilization summary for required architecture based process for slices, lookup table and flip-flop pair for architecture. Then we go to the path delay time and minimum period and clock frequency ratio and the latency time for timing summary analysis report for required PCT transformation architecture. These are the final output for our PCT architecture output.